and I'm the Principal and Director of Sky Academy. And we've been going through our work with integration, and in the last episode what we got up to was we looked at the definite integral. Okay, we looked at the definite integral, and with the definite integral we looked at and we realized that differentiation and integration are just reverse processes of each other. So the way we integrate something, or the way we find the area under a curve, or integrate something, is really just opposite of what differentiation is. Okay, we just find the primitive of the curve. Okay, so and we realized that that was called the first fundamental theorem of calculus. Now we're going to apply that to curves in general where we don't have upper and lower limits. So this is basically where indefinite integrals come into play. So an indefinite integral, the indefinite integral, is an integral expression that does not contain upper and lower limits. Okay, so if you look at this integral expression there, there's no lower limit here and there's no upper limit there. See how it's missing that? All right. So basically what we're doing is we're finding the rule which gives us the area under a curve between any limits that we might want to choose. Okay, because we're not given any specific limits to find the area between. So it allows us to integrate to find the rule that gives us the area under the curve. Got that? And this is basically what we do. We just find the primitive of the expression that's being integrated. Right? So we've got ax to the power of n, a being the coefficient, n being a power. How do we integrate that? Well, we integrate that basically by adding 1 to the power and dividing by that raised power. Okay, so we add 1 to the power, so it becomes n plus 1 is the new power, and we divide by the raised power, which is n plus 1. Okay, so the other thing that you will notice by me giving you this rule is in big fat red letters I've got a plus c. Right, now the plus c is very important when we're doing indefinite integrals. When we're doing definite integrals, we don't need a plus c, but when we're doing indefinite integrals, we definitely need the plus c. And what the plus c does is it gives us the constant that would have been there that got disappeared if we were to differentiate. Okay, so because integration is the reverse process of differentiation, right? If it recognizes that to differentiate this means that a constant was there that may have been there, I should say may have been there, that would have disappeared in the process of differentiating. All right? And it recognizes that when we integrate, we've got to account for the fact that a constant went missing, that a constant disappeared. Okay? So that's why we have a plus c there. And every time we do indefinite integrals, we need to plus c. Got it? We need to plus c. So let's have a look at how we might do each of these. And I'll do these examples in blue, but what you will notice is that I'll add plus c in big fat red letters, okay, just so that you know that that went missing, okay, that we need to account for that, okay. So let's have a look. Integrate 2x. So we've got an integral sign here, all right, and what we're integrating is we're integrating 2x, right? So 2x has a power, that power is 1. We raise the power of 1 by another 1 to x to the power of 2, and we divide by the raised power, okay? So that becomes x squared, because the 2 here cancels with the 2 there, all right? But it's not just x squared, because we need to account for the constant that went missing, so we need to plus c. let's try this example here, shall we? So we've got 21 x to the power of, we raise that power by 1, so it goes up to 7, and then we divide by the raised power, we divide by 7, which gives us 7 and 21 cancel to 3x to the power of 7, right? And we need to remember to account for the constant, a constant that might be there, okay? The last one will be a polynomial expression with more than one term. It's got a number of terms. So let's work this one out. Alright, so by now we will have got the hang of this. So let's work this out. So 4x to the power of 4 over 4 minus 2x to the power of 3 over 3 plus x to the power of 1 becomes x to the power of 2 over 2 minus 6, and that's x to the power of 0, so it becomes x. So minus 6, so see this minus 6 there? That becomes minus 6x. Got it? Let's simplify this expression, alright? So it becomes 4 cancels with 4, so it becomes x to the power of 4 minus 2/3 x to the power of 3 plus x squared on 2, or you can write another way. Let's be consistent with what we've got here. So let's make it a half x squared minus 6x. Now, we've got to remember, I've got the red pen out already, to plus c. Now, I want to introduce you to another rule, which is basically the chain rule in reverse. Okay, so the chain rule, or the function of the function rule in reverse. Okay, so it's finding the primitive of by taking into account the function of a function rule. And this basically is where you have ax plus b to the power of n. When you're integrating that, okay, the indefinite integral for ax plus b to the power of n, where a and b are just numbers, okay, then basically you take that expression, that binomial expression, you raise the power by 1, divide by that raised power, but you also divide by the coefficient of the x, okay? So let me do this example with you, alright? So basically what you do is you write the binomial expression, raise the power by 1, so 2 ends up becoming 3, divide by the raised power, but you also have to divide by the coefficient of the x, which is 1. So your answer should be x plus 3 cubed on 3. Got it? Now let's just make this official by adding c on the end, and that is how you do a indefinite integral that takes on a binomial form. Okay, let's do this one here. This time we've got a coefficient for the x, and you'll see how we treat it. Okay, so 7x minus 4 all to the raised power of 7, divide by the raised power, and we also need to divide by the coefficient, which is also 7. Okay, so this 7 represents this raised power. Okay, we divide because it's a raised power, and this 7 represents the coefficient of the x. So altogether, our answer is 7x minus 4 all to the power of 7 over 7 times 7, which is 49. And then we add c on the end. Okay, so if nothing else, what I want you to get out of this episode is that the indefinite integral, when we integrate an indefinite integral, two things. The first thing is we find the primitive of the function that's being integrated, and the second thing, we need to add the c. We need to add our constant at the end. Okay. Thank you very much for watching.